All right, so the trend you should have seen here was that as we added more sides to the base, that actually increased the area of the base, which then increased the total surface area. Super cool, right? And so we're heading towards, we have 3, 4, 5, 6, 8 sides. We're heading towards actually a cylinder being the prism that has the largest surface area. So if we had 100 sides, it would be getting closer to a cylinder. Not quite there yet. Notice how the total surface areas are getting closer and closer as we add more sides. The differences between the two are decreasing, and that's just, you're going to see that trend more and more as you continue. I saw this, it was in my slides. I thought of some of you. There's a quick laugh for you. Now, let's just refresh our memories on how to find area of things. Of a triangle, we take the area of the base, multiply it by the height. So 3 times 4, and then we divide it by 2. So that gets me 12 divided by 2 is 6. Remember, when I talk about area, we are meters squared. To move on to different triangles we may see. My base is 10, so it's still the base of the triangle. Now the height is confusing here. A lot of students will choose 15. Please don't. Instead, my height is this value here. So it's 10 times 12, which is 120. And then we divide by 2. I'm sorry for the baby in the background. Graham is going to bed, and he loves bedtime so much. As we move on to a trapezoid, some of you have seen this in the Mega High, which is great. You do have a lot of Mega High due on the 24th, so please do not neglect that over the next couple of weeks. As we move on to this, we know that to find the area of a trapezoid, we take the two bases, so 7 plus 10, and then we find the average of the two bases. So in this case, 7 plus 10 divided by 2, 17 divided by 2 is 8.5. And then we multiply that by my height, which is 4. 4 times 8 is 32. Half of 4 is 2. And so then we get 34 meters squared. So moving on to investigation 2.2. 2.1 was really easy, right? We talked about how surface area is affected as we add number of sides to your figure. And the closer we get to a cylinder, the greater the surface area is, with the cylinder being the greatest surface area. Now, when we think about volumes and how volumes relate, then we're going to be thinking about what volume is. All volume is are layers of identical cubes. So it's really easy when we talk about squares because, well, squares, the cubes fit really easily into square prisms. They don't work so easy in other shapes. So let's talk here first. To find the volume, I find the area of this base. So 4 times 4 is 16. And then I figure out how many of these 16s can I stack on top of each other. The key to this is that I know that each one of these cubes has a height of 1. And so if I have a height of 9 here, I say, how many 1s can I fit into 9? And so that'd be 9 layers. And so we take, well, there's 16 in the bottom layer. Then if we add 16 more for the second layer, and then the third and the fourth and the fifth and so forth, really what we're doing is we're taking that bottom layer and we're multiplying it by whatever the height is. Because it's how many layers, how many 1s you'll get. So let's go ahead and do this. If I think about 6 times 9 is 54. 9 times 10 is 90. If I add those together, then I get 144. As we're talking about volume, don't forget that we're talking about units cubed. The reason we're talking about units cubed, again, just as a refresher, let's call these meters. And so we went through and we did 4 times 4 times 9 to get me 144. Great. But what we didn't talk about were the units that were on here. And the units are being multiplied too. And so I have a meters times meters times meters. So we have meters times meters times meters. And because we don't actually know much more about this, meters times meters would be meters squared. And then meters times meters times meters is going to be meters cubed. And that's where we get the cubic units from. Now, as we continue to think about prisms, square prisms are easy. When we come down here, though, we've got, we've got a triangular prism. This is where we go to what we talked about. How do I find the area of a triangle? And I know I look for that. In this case, the right angle helps me find my base and my height. And so I know that the area of the triangle is 4 times 4, which is 16. But then I need to divide that by 2 to get me an area of the base is 8. Well, then how many bases can we stack on top of each other? Well, we have 9 rows. There should be a 9, sorry. And that's 72 units cubed. You should notice that when I take a square and I cut it in half, hey, I make a triangle. Up here I had 144 units cubed. If I cut that in half, I get my 72 there. What do you know? It's magic. So, as a rule of thumb, this is how to find the volume of any prism. Go ahead and pause the video and put this in your vocab. All right, welcome back. You have added this to your vocab, and I really quickly gave this to you, and here is why this works and how we saw this in the previous page. What we did with both, bring this down a little bit. With both of these shapes, we first found the area of the base. And I figured out how many bases can I stack on top of each other. The height. That's what we're doing here. When we find the volume of any prism, we need to find the area of the base and then see how many of those bases we can stack, aka what is the height. This equation is going to be really big for today. Here's that chart again, looking at surface areas, looking at areas on top and bottom. All right, so let's go ahead and check out A. Go ahead and pause the video. Work on A1 and 2. 2 I kind of gave to you already. And then the next video will show how to solve these.